Hello, I'm Cheryl. In this problem, we have an application where we're looking for three positive numbers, x, y, and z, such that the sum of the numbers is 30. But we're looking for the sum of the squares of those numbers to be a minimum. So to begin with, we have to come up with a function that I want to minimize. So let me begin by just creating an equation. We'll say s equals x squared plus y squared plus z squared. That represents the sum of my squares, the thing that I'm trying to minimize. All right, well, I'm looking at this and I would like to write it as a function of just two variables, not three. So I'm going to use the secondary equation to help me do that. What I'll do is I'll solve this for z and say that z equals 30 minus x minus y, and then substitute that into my formula. So that sum formula is going to be x squared plus y squared plus the quantity 30 minus x minus y, that quantity squared. So notice now I have this written as a function of x and y. So let me rename this. I'll call this the function s of xy equals x squared plus y squared plus the quantity 30 minus x minus y squared. Okay, now that I have this written as a function of two variables, I want to find the critical numbers. So I need to find the partial of this function with respect to x and with respect to y. So let's first of all get the partial with respect to x. So again, I'll treat y as a constant, so this will be a 2x plus 2 times the quantity 30 minus x minus y to the first power times negative 1, which will give me 2x minus 60 plus 2x plus 2y, which is going to simplify to 4x plus 2y minus 60. Okay, now let's get the partial with respect to y. So the partial with respect to y is going to be 2y plus 2 times the quantity 30 minus x minus y to the first power, again times negative 1, which gives me 2y minus 60 plus 2x plus 2y, or 2x plus 4y minus 60. Okay, now I know critical numbers happen when either one of these partials are undefined or when they both equal 0. Well, taking a look at my two partials, neither one of them will ever be undefined. So what I need to concentrate on is when they're both equal to 0. So let's go ahead and take them both equal to 0. So we'll say that 4x plus 2y minus 60 equals 0, and 2x plus 4y minus 60 equals 0. And I have a system of equations. So what I'll do is I will take that bottom equation and multiply both sides by a minus 2. So that turns my system into the system 4x plus 2y minus 60 equals 0, and a minus 4x minus 8y plus 120 equals 0. When I add these two equations together, I get 0x and a minus 6y plus 60 equals 0, or 60 equals 6y, and y equals 10. Now plugging that back up into one of the original problems, or one of the original equations, I'll have 4x plus 2 times 10 minus 60 equals 0. So 4x, this will be plus 20 minus 60, so that's going to be minus 40 equals 0. 4x equals 40, and x, again, equals 10. So I have a critical number at 1010. Now I have to determine whether that critical number is a minimum, a maximum, or maybe neither. So I'm going to use my formula that says that if I take the second partial with respect to x at the point 1010, multiply it by the second partial with respect to y at the point 1010, and then subtract the mixed partial at 1010 and square it, we're going to look to see whether this is positive, negative, or equal to 0. Now, notice here, this is the general form. I'm using my function s, but it's the same thing whether you call the function s or the function f. So let's go ahead and take a look at those second partials. Well, here's my first partial with respect to x. The second partial is just going to be a 4, and it doesn't matter what point I plug in, 1010 or any other value, the second partial is going to be 4. And if I look at the second partial with respect to y down here, again, the second partial with respect to y is also 4, regardless of what point you plug in. So the first part of this formula is just 4 times 4. Now I need my mixed partial. So we'll go back to my partial with respect to x and now differentiate this with respect to y. And the mixed partial then is going to be 2. Again, it's a constant 2. It doesn't matter what value I'm plugging in, even though in this case I'm plugging in the point 1010. So this will be 2 squared. So I have 16 minus 4, which is 12, which is greater than 0. Now that tells me I do have either a minimum or a maximum. To determine which one, I need to look at the second partial with respect to x at the point 1010. We've already discussed that this is 4. Because this is a positive number, that indicates that there's going to be a relative minimum at the point 1010. Okay, now we're really looking for the minimum value, not necessarily the relative minimum, but the absolute minimum. So it's also possible that we may have a minimum at one of the boundary points. But if you take a look at my secondary equation, x plus y plus z equals 30, I notice that the boundary is all going to be in the part of the Cartesian plane where the x, the y, and the z are all positive. Okay, which means that that piece that we're looking at will have a boundary that's open. Okay, so that tells me that I'm not going to find any critical or any extrema on the boundary. So I know that my relative minimum is going to happen when x equals 10, y equals 10, and the only thing that's missing here is I've never calculated z. Well, I can use my secondary equation and notice that z is 30 minus x minus y. So that's 30 minus 10 minus 10, and that third number z is 10. I hope that was helpful. Thanks.